What we accomplished in our previous tutorial was a red cube. Now, if you look on page 72, this is what you should have when you run your program or your little software application that you've programmed up successfully. So now we're going to be working on page 76. We're going to be working on trying to get a colorful cube, and then we're going to go ahead and work on animating it, making it bounce around the screen. But before we do such a thing, and before we complete such a task, I would like to just go around manipulating and modifying or editing a couple of lines that are in relation to the camera and the cube to show you that when you change these numbers up, the camera can be to the left or the right, and the cube can be to the left or the right. Before we get started, this is what your syntax and your code should look like. Alright, so that's all the code that you should have. This is your void display. All this stuff should be inside your void display. And when you run this code, this is what you should have. We'll go ahead and do a rebuild, and we will build and run. You should have a red cube. Now, let's say for example we go into this line right here, camera X, and right now the camera is set at 8 units on the camera Z axis. Okay, so let's change this up and let's see what results we get. Make it a 5. Where do you think our cube would be if we put that to 4? Because X is going left and right, Y is going from top to bottom, Z is going forward and back. So if you change this number to 4, it will probably make it a little bigger or a little smaller. Let's check it out to see what this number does. F9, and it makes it closer. Because the camera is now closer to the cube, because we're modifying the location of the camera now. Okay, and the camera is 4 units instead of 8 units, so that means the camera is closer to the cube now. Let's put it back at 8. F9. And now the camera is farther away. Okay, so let's say we want the camera to be to the left. I guess I would do X. We would be working with the X axis, and we would give it like a -4. So let's try it out. F9. Oh, this puts the camera to the left, not the cube. So the cube's to the right because we moved the camera to the left. All right, let's move the camera to the right now. So if we're going to move the camera to the right, we want that to be in a positive 4 direction on an x-axis. Let's take the negative sign out, and let's press F9 to check our new results. So now our camera is to the right of the cube. So now, let's put that back to 0. And we want to start moving our cube instead of our camera. So let's say we want our cube to the right of the camera. Right now, the cube is on a location of -2 on the y-axis, which puts it further away from us. Let's change this location first and put it at 0 to see what result we get. Okay, so now it's like we're looking dead at it. Puts it at a 0, 0 origin. Let's give it back to -2. Now the cube is beneath us a little bit. Okay, so when you're working with the cube location X, Y, and Z, you're moving the cube, not the camera. Okay, so we'll go ahead and move our cube to the left a little bit. So we'll put -6. We'll press F9. It should show up at the left a little bit. And there you go. So all the way to the left. You can hardly see it. We moved it off the screen a bit too much. Let's go and change the number up. -3. F9. As you can see, the cube is to our left. Let's move it to our right. How will we move it to the right? It would take away the negative sign. It will be on the right hand side. Hit F9 for run. And now the cube is to the right. Okay, so you want to mess around with these numbers right here, and these numbers will give you, of course, different results for every single different number that you put in. It'll give you different results. Okay, so now we're going to go ahead and enter syntax and code so that we can add a little bit of interesting colors to the cube. Red is not looking so interesting to me, so of course everybody prefers their own special color. I like the color green. We'll leave it a red for now because that's the color that the book is working with. But in situations like this, we want to make it interesting, so what we would do is we would go about adding various colors to the cube. We're going to go ahead and enter the syntax for that right now. Okay, and right beneath our GL clear and above our GL use program, we want to put GL clear, GL color buffer bit, semicolon. What this says is GL clear sets the bit plane area of the window to values previously selected by GL clear, or GL clear depth, or GL clear stencil. Multiple color buffers can be cleared simultaneously by selecting more than one buffer at a time using GL draw buffers. GL color buffer bit indicates the buffers currently enabled for writing color. Now we want to go into our frag shader. So what you want to do to access your frag shader, you double click on these blue folders that you have over here. Locate your frag shader. Double click on it. We'll go down to version 4.30, which means 4.3. And we want to add the line like so. In vec4 varying color, semicolon. Now what this line does, vec4 is a floating point vector with 4 components. It can be initialized by providing a scalar value for each component, providing one scalar value. This value is used for all components. Providing a combination of vectors and scalars, the respective values are used to initialize the components. The arguments of the constructor must have at least as many components as a vector that is initialized. Down beneath our void main void, we want to enter this line like so. This line says color equal to varying color. That's a capital C. Don't forget your semicolon. And we want to cancel out this line right here because this is the line that is making our cube red. Because as you can see right here, this is R for red, this is G for green, this is B for blue, this is A for alpha. Okay, so this right here means that the cube is red. Now we want to go into our vert shader. We'll cancel that, we'll leave it open. We want to go into our vert shader .glsl file, which is short for Graphics Library Shader Language. Then we want to add the following line, like so. We want to add out vec4 varying color. Then you go down to GL position and you enter this line like so. You enter varying color equal to vec4 position 1.0 multiplied by 0.5 plus vec4 0.5 comma 0.5 0.5 0.5 and a semicolon. Don't forget your semicolon. We'll go ahead and cancel this line out since we have no need for animation right now. Let's tidy up a bit. You don't want your code to get too messy because things start to get hard to read. Now that we've entered this code in the syntax, let's see what we have. Let's see what the results are. And there you have it. You have a colorful cube, which is a lot more interesting just one solid red color, which is red. I said he put my favorite color, green, at the back of the corner. If you've gotten to this point successfully with no issues, then I'm quite sure that you're tired of seeing just a solid red cube, or a solid colorful cube sitting in just one location. You want this cube to move around and have some type of motion about it, like we did to our triangle. So we're going to go ahead and program that cube to move around and to bounce around, and it's going to be very interesting and very fun. And if you code everything correctly to a T without any problems or issues, and if you don't miss any semicolons, you don't miss any capital letters or lowercase letters, if you program everything perfectly, you will like the fruits of your labor. So let's go ahead and get started. Okay, so you're going to find your view matrix line. This is the line that you want to type beneath, and we're going to go ahead and start entering our code. It's going to be very, very tedious. There's going to be a lot of programming, a lot of typing that you're going to need to do. So crack your fingers, pop your neck, roll your eyes, shrug your shoulders, and do whatever you need to do, and get ready to code. Okay, so this is the same thing as this, what you can do. You just copy and paste that, because it's going to be the same thing. This is GLM Vec3 1.0F 0.0F 0.0F. The line above it is not the same. The 1.0 is in the middle. Down here, the 1.0 is on X. This is X, Y, and Z. Because we're dealing with matrix right now. Matrix is in relation to X, Y, and Z axis. Okay, so RMAT is short for rotate matrix. TMAT is for translate matrix. So you have translated matrix and you have rotate matrix in graphics library math, vec3, sin, and cos. Sin is for sine, and cos is for cosine. Let's go ahead and copy this again. Now this is graphics library math vec3 0.0f, 0.0f, 1.0f. Now we got a 1 for representation of each axis. For this one is a representation of y, this one is a representation of x, and this one is a representation of z. Okay, and we want to type model matrix is equal to translate matrix multiplied by rotate matrix, semicolon. And keep in mind, these are not semicolons right here. These are commas. So don't make that mistake and put semicolons when you need a comma there. Okay, when you look at all this stuff that you typed up, looks rather cryptic. Go down to bottom in mat, and let's cancel this line out. Let's run our results and check to see what we have. Oh, we have an error. It says TMAT was not declared in the scope. Did you mean MMAT? RMAT was not declared in the scope. Did you mean MMAT? No, I don't mean MMAT. So what we need to do is we need to declare TMAT and RMAT. We'll go up to the top here. And we'll add TMAT and RMAT. Now that those are added, let's see what results we get. We get a blue. There's no warnings, there's no errors. Let's run and let's check to see if we have the fruits of our labor. It's pretty neat, huh? So what we can do, we can go ahead and delete or code out GL point size. That's not going to make a difference. In that tutorial, is pretty much it for the end of it. Thank you for watching, and I'll see you in the next tutorial. This is Jesus Christ.